6 is enthalpy changes. Pretty much getting into some new stuff and a little bit more math and actually the funner parts of chemistry. So the first part is just basically definitions and understanding what enthalpy is. So 6.1 is a basic introduction. In a chemical reaction, you have energy that changes. And energy can be any form of heat, light, electrical charge, sound. All those are types of changes in energy. And every reaction has that. It could be a lot, like a combustion reaction, or it could be a little, like dissolving salt in water. So two types of energy changes, or these are types of energy changes. Burning fuel, the engine gets hot. Okay, we know that's a chemical reaction because of change of temperature. Fireworks explode and get heat and sound and light. Yay, 4th of July. Oxidation of food, it's burning of calories, keeps the body warm and able to use. There it is. Goes right into the stomach. Photosynthesis, basis of life, is really important to use the CO2, produce carbohydrates and the chlorophyll. Okay. And even solid to liquid is a type of energy change. It absorbs energy and turns into a liquid. So they're all types of changes in energy. Alright, 6.2 is what is enthalpy change. So there's two types of chemical reactions that occur in energy, exothermic and endothermic. Exo is releasing of energy, like exiting. Temperature increases over the surroundings. Examples would be combustion, oxidation, and just dissolving calcium oxide in water produces calcium hydroxide, the base. Endothermic, energy gets absorbed, so it takes in energy. Temperature decreases the surroundings. Thermal decomposition, so heating something up, is an example. Photosynthesis takes in energy, and dissolving ammonium chloride actually reduces the temperature, and it's one of the components of an ice pack. So here is the combustion of fire. You have water and calcium oxide makes the temperature increase. Burning is something, so anytime you add heat to anything, you are making it endothermic because you're adding energy in. Photosynthesis, it takes in the energy for the photons from the sun. Alright, so here is a question. Classify each process as exothermic or endothermic. We have the burning of magnesium. So burning of magnesium. B, we have the crystallization of copper sulfate from a saturated solution, so it recrystallizes into a solid. Thermal decomp of magnesium nitrate. The fermentation of glucose in yeast, using yeast, and the evaporation of seawater. So, take a few minutes, pause if you need to, try to think about which ones are exo and endothermic. The burning of magnesium is exo. It's a combustion of magnesium. It produces light. The recrystallization of copper sulfate from saturated solution. So it's forming a liquid into a solid. In this case, it's exothermic. Thermal decomp is the key in this one. It's adding energy in, so it's endothermic. If you're not familiar with the fermentation process, it is an exothermic reaction. And evaporation takes energy in, so it's endothermic. Alright, enthalpy. So enthalpy is a basic term for energy exchanging in a chemical reaction. It's energy specific for chemistry. It's a basic change between what energy it is to make the products and how much energy it takes to make the reactants, and the difference is that enthalpy change. Units is kilojoules per mole. And you can make a profile diagram basically showing how the changes are occurring in enthalpy between products and reactants. Here's an example of an exothermic reaction. You have your reactants, and it takes a certain amount of energy, which you can find. To make the products, it takes a certain amount of energy. So notice that the reactants is larger than the products. So if you do products minus reactants, you get a negative number, hence exothermic reaction. Also a clue is it's a combustion reaction, which is always exothermic. So profile design is exothermic because the reactants are larger than the products, so you get a negative number, exothermic. Here you have your products are higher than your reactants. So does this enthalpy profile indicate an exo-endothermic? Since the product is larger than the reactants, you would get a positive number, hence the positive 572, and it's endothermic. So that plus automatically tells you it's endothermic. Alright, homework question number 1, draw an enthalpy profile design for the combustion of sulfur to form sulfur dioxide. And then B, an endothermic reaction, water plus carbon makes hydrogen gas and carbon monoxide. Alright, 6.3 is all about definitions. First, understanding what standard conditions mean. So this is a standard for all enthalpy changes. It does change. The numbers do change depending on pressure and temperature. So they need a standard. In this case, about 100 kPa, which is normal atmospheric pressure, basically 102. Temperature, room temperature, 25 degrees Celsius, which is 298 Kelvin. And this is for normal substances, solid, liquid, and gas. So basically it's saying at what phase, at normal pressure, normal temperature, will the substance be. The theta shows that it's under standard conditions. So that theta means it's at 298 and 100 kPa. So for example, combustion of methane produces carbon dioxide and water. The standard enthalpy is negative 890.3 kilojoules per mole, which would look like this. From previous example we saw, reactants would be on top because it's an exothermic reaction. Reactants always on top, products finish on the bottom. The net is negative, and actually negative 890.3 kilojoules per mole. Alright, so you have different types of enthalpy changes depending on what type of reaction it is or what's happening. You have the basic formation. So formation is forming a compound. A combustion reaction, pretty self-explanatory. Neutralization is an acid-base reaction. Solution is making a solution. Optimization is that a molecular compound changes to form its elements. So basically a diatomic element or compound to a single atom. And then the hydration of anhydrous salt. Pretty simple there. So here are the 7 types. Probably a good idea would to make note cards or some other way to study these definitions. So you have a standard enthalpy of reaction. R stands for reaction, and the definition is pretty basic. It's the amount of reactants shown in the equation to react to give the products under standard conditions. So this is your general enthalpy. It's at standard room temperature and pressure. An example would be a simple reaction of hydrogen and oxygen. This also could be a combustion reaction. Delta H is, in this case, negative 286 for production of water. And it can either be endo or exothermic. It just depends if it's a positive heat change or a negative. F stands for formation. 1 mole of compound is formed from its elements. So the last example could be a formation reaction. Standard states. Here you have an element iron plus its oxygen makes a compound, so it's a formation. It has to come from basic elements. You can't have a compound in the reactant side on a formation reaction. In this case, it's negative 824, and it could be either endo or exothermic. A combustion reaction stands for the C. Pretty easy, burns with oxygen. Standard states. Here you have sulfur dioxide being produced. It's always going to be an exothermic reaction. Just the definition combination of combustion is always producing heat. Alright, N stands for neutralization. This is defined with an acid and a base. So here's an example. You always make a salt and water. So you always have an acid and a base. In this case, it's negative 57.1, and it's always exothermic. Every time you make a neutralization reaction, you're always generating some type of energy. Solution, basically just dissolving a solute in a solvent, generally water. Here you have a sodium hydroxide solid, and you're making aqueous. In this case, it does generate quite a bit of energy. If you remember making your titration base, you do feel a temperature change. And most of the time it's exo, but sometimes you get endothermic reactions like dissolving baking soda in water is actually a endothermic. Atomization. As defined before, you take a gaseous atom from its element. So you take its molecular structure and you produce a single atom from it. Here you have hydrogen diatomic producing 1 hydrogen atom. This is always going to be endothermic because it takes energy to break that bond. So you have to put energy in to break apart hydrogen, molecular hydrogen. And hydration, forgot the H. 1 mole of a hydrated salt is formed from its anhydrous. So basically adding water. That's what hydration is. You gotta hydrate to stay healthy, especially in warm days. So hydration, adding water. In this case, you take an anhydrous salt, adding water to it to make it an hydrate. Sorry. In this case, it's negative 55 kilojoules, not much energy, and it can be either endo or exothermic reaction. Alright, so those are the 7 you want to make sure you know. And second homework question is pretty easy. All you need to classify the reactions as heat of reaction, or enthalpy of reaction, enthalpy of formation, or enthalpy of combustion. You got magnesium carbonate producing MgO and CO2. Graphite and water, or high oxygen making CO2. HCl and ammonia making ammonium chloride. Hydrogen plus oxygen making water. And there are multiple answers for these that you could answer with. So make sure you include all possible enthalpy changes for each ones that can have multiple answers.